Welcome to the task description of the Sri Lankan Robotics Challenge University Category Competition. The University Category Competition will be held in two stages on 2 days. The Day 1 competition is the selection round in which we will choose the best teams to compete in the Grand Finals. This video will walk you through the University Category task. Please note that the arenas shown in this video are sample arenas. The final arena will be different but will obey all the specifications provided in the task document. The demonstrations show only one method of navigating the robots. Other strategies are also acceptable. First, let's have a look at the task for the Day 1. During the Day 1 competition, your robot should navigate through 4 regions. Region A, Towers of Hanoi. Region B, Line Maze Following. Region C, Cave Navigation. And finally, the Region D, an elevated arena. Before getting started with Region A, let us first understand what the Towers of Hanoi problem is. This task involves moving a set of 3 boxes from one square to another square using the Towers of Hanoi algorithm. To start the task, the boxes should be placed in one square, with the largest in the bottom and the smallest on the top. While moving the tower, you can use one additional square to exchange the boxes, but a larger box should never be placed on a smaller box. This animation shows a sample demonstration of solving the Hanoi problem for 3 boxes. Let us move on to the task in Region A. You can choose one between 2 options to solve the Region A task according to your preference. Both methods carry equal marks. One is a simulation on VBots. The second method is a physical task. At the start of the game, you will be given 2 numbers. First, let us have a look at the simulation task. Write your code to read the 2 numbers from the console as inputs. In this task, you will be given a 7x7 grid arena. The walls highlighted in yellow are fixed, but the rest of the walls will be different. The squares are numbered from 1 to 3, but the labels will not be present on the arena. The robot will start the task from the square in a corner. 3 boxes of specific sizes and colors as given in the task document will be placed in the other 3 corners randomly. Your robot can navigate through the grid maze, pick up the boxes in any order, and build a Hanoi tower on the square with the given first number. In this demonstration, the first number is 2. Then the robot will move the Hanoi tower to the square with the second number. The second number in this demonstration is 3. During this task, the robot can place any box in any of the 3 squares for exchanging, but a larger box should not be placed on top of a smaller box. If you choose the physical method, your robot will start the task from the starting square of the Day 1 arena and should make its way to the green square to start the Region A task. The arena for the physical task is a tree. The boxes will be positioned randomly on the squares on the left side of the robot in the tree. The robot should pick them up in any order and build the Hanoi tower on the square with the first number. Then the robot should move the Hanoi tower to the square with the second number. In this demonstration, the first number is 1 and the second number is 2. During this task, the robot can place any box in any of the 3 squares for exchanging, but a larger box should not be placed on top of a smaller box. You are allowed to proceed on to the rest of the task even if your robot does not attempt but does not complete the Region A task. In that case, if you do not attempt the task at all, you would not receive any marks for the task A. If you attempt but fail to complete, you can proceed with the penalty. Now let us have a look at the task in Region B. If you attempted the simulation method in Region A, your robot should start the task from the starting square and follow the path up to the blue square. If you attempted the physical task, your robot should start region B from the green square. Then it will navigate through the line maze and make its way up to the red square. The positions of these color patches are fixed, but the paths within the 4x3 grid can be different in the final arena. Here you can see a sample demonstration of how your robot should navigate the region B line maze depending on the method you chose for region A. Next, in region C, your robot should navigate through a cave area which has obstacles placed on the path randomly. You can identify the end of this region by a wide white patch. As the final task for day 1, your robot will next enter an elevated arena where it should follow arrows that direct it to the end of that elevated area. Finally, it will follow a line segment and finish the task by arriving at the ending square. Teams that perform well on day 1 competition will be selected to compete in the grand finals on day 2. The sample arena for day 2 is shown here. The region A from day 1 is not used in day 2. The regions B, C, and D from day 1 become regions A, B, and C in day 2. An additional region D task is added, which is called the number construction arena. The region A in day 2 is slightly different than the task that we did in region B in day 1. As in day 1, the robot should start from the starting square and make its way up to the blue square at the beginning. Then the robot navigates the line maze. The maze on day 2 will be different from the one on day 1. In addition, on day 2, there will be a certain number of white boxes within the grid. The robot should traverse and count the total number of boxes in the line maze area, like in this sample demonstration. The tasks in region B and C on day 2 are identical to the tasks in region C and D on day 1. However, the placement of obstacles and the arrows shall be different. As the robot leaves the elevated arena in region C on day 2, it will enter the region D, a 7-segment number construction area. It is a 4x3 grid on which we already have a number created in 7 segments. The sides of the boxes used in this task will be white while the top and bottom are red. 5 additional boxes of similar specifications will be present at the places highlighted on this slide in blue. However, in the actual arena, they will not be highlighted in blue. The numbers are formed using the boxes. The formations for each number is shown in this slide. Your robot can enter the grid, traverse it, and identify the number. Then it should perform the following calculation using the numbers of boxes in region A and the number identified in region D. The last step is to modify the 7 segments of the current number to form the result of the calculation. You can do so by removing boxes or placing boxes. Additional boxes will be present in these locations if you wish to use them. The boxes that you remove can be placed anywhere on the grid outside of the 7 segments so that the number is clearly separated and identifiable. You can see an example demonstration of creating 3 from 2. However, a different strategy that adheres to the mentioned rules is acceptable. The task is complete once the number formation is done. The teams and the robot should adhere to all the rules and regulations in sections 2 to 6 in the task document. The judge's decision would be the final. Please reach out to us through the Facebook group if you have further questions. Good luck to you all.